Hi, this is Michael Koenigsman from Keysight Technologies. The second part of the series will cover the identification of transmitter gain imbalance and what could be causing it. A transmitter gain imbalance, or IQ gain imbalance, in general describes the differences of the amplitudes of the I and Q signals of a complexly modulated signal. To measure the gain imbalance, the amplitudes of the I and Q signals are compared against the amplitudes of a reference constellation, shown as 4 gray crosshairs in the constellation diagram. They mark the positions of the expected constellation points. Transmitter gain imbalance occurs when the amplitudes of the two signal components are of different amplitudes. The constellation diagram on the right-hand side shows a constellation distorted by the transmitter gain imbalance. It can be observed that the width of the constellation is different from its height. The optical modulation analyzer can be set up to measure the gain imbalance in the optics properties window, which can be found below the constellation. The OMA reports a gain imbalance of 4 dB, which means that there's a difference in the amplitude of 4 dB between the I and Q signal. Usually the aim is to achieve a gain imbalance in the order of a few tenths of a dB. Here's a simplified block diagram of a single Mach-Zehnder modulator. Transmitter gain imbalance could result from different signal levels for the I and Q signals used to drive a Mach-Zehnder modulator. Different signal levels of the data signals may be responsible for the imbalance, as well as different gains of the driver amplifiers for the modulator. For troubleshooting purposes, it should be considered that a combination of different signal levels and the different gains can also be the cause of a transmitter gain imbalance. The effects of gain imbalance are best viewed in the constellation diagram. As one can see, the spectrum in the upper right corner shows no change as a result of the gain imbalance. The constellation diagram on the left shows the effect of a variation in gain imbalance of 4 dB plus minus. Using the example of a QPSK, usually the imbalance is static as shown in the constellation diagram on the right, and with a neglectable gain imbalance of minus 0.013 dB. For this illustration, the gain for the I and Q path was varied dynamically over time. The optical modulation analyzer can be set up to measure the gain imbalances in the optics properties window, which can be found below the constellation diagrams. The lower right-hand side visualizes the gain imbalance over time. A small note that only the absolute value of the gain imbalance is displayed unless a BER measurement is active and the OMA software is able to sync to a PRBS. I hope you enjoyed the transmitter gain imbalance video. If you find yourself interested in OMA software, please visit Keysight's website to discover more helpful content. And don't forget to subscribe to the Keysight NDC channel. Bye bye.